a multi-landlord public cloud. We know what multi-tenant clouds are, so what's a multi-landlord cloud? Well, I'll get into that in a little bit. So first, there's the obligatory credits. You know, sort of like in the movie, these scroll by really quickly. One person I do want to mention is Eran Krieger at BU. This has really been his idea, his vision from the inception. But anyway, I guess I wanted to start out by backing up a little bit. So I realized talking to people just now that, you know, well, people will either really like this part or really hate it, so we'll see. So what is the cloud? You know, we all sort of think we know what cloud computing is, but what makes it cloud computing? You know, you've got infrastructure as a service, you've got platform as a service, you've got software as a service, you've got everything as a service. You know, well, like the parable of, you know, the three blind men and the elephant. Let's say you've got three engineers and their manager sends them out saying, what is this cloud thing? Well, you know, the first guy sees infrastructure as a service. Oh, this is really simple. This is virtualization. I've been doing this for years. Okay. The next guy has to look at platform as a service. He's a little bit more confused. You know, he's looking at this and saying, well, I think it has something to do with containers and frameworks and stuff like that. And then the poor guy who gets sent to look at software as a service, he can't tell. So basically, what unifies cloud computing is this. Cloud computing is the act of paying someone else money to use their computers. And that's really, in a lot of ways, a wonderful thing. It has a whole bunch of benefits ranging from the really technical to the pure business. I mean, on the technical side, you get statistical multiplexing. I mean, that's why they don't give each of us a stretch of highway about a 1/4 inch wide. Instead, we get the highway for, you know, one lane for, you know, the time that we're driving on it. If you lump a bunch of resources together and have a bunch of people share them, it is more efficient. You get shared infrastructure. Anyone who's put air conditioning into a small machine room has got to realize it can't cost 10 times as much to put 10 times as much air conditioning into a bigger room. It certainly can't cost 100 times as much to put 100 times as much AC into a building that was designed to hold computers and be cooled. You get all sorts of efficiencies of management. I mean, just, you know, what Jesse was talking about, or talking to him just now, you've got enough people that they can actually understand the software that they're working with. You can have people looking at different parts of it. You can have people writing the code to automate things across thousands of machines instead of having like 2 people running around trying to fix everything. And then finally, you know, there's the business benefits. And you can't underestimate those either. If you've ever worked for a startup, I actually was in industry for years before I went into academia. You realize money's expensive. It's hard to buy things. There's things like salaries you can use it for. And worse yet, not only is there the risk of spending too much money, there's the risk of spending not enough. You look at something like, say you go and you you look at something like Farmville or something like that. If you were buying servers to do an application like that, it would get really popular, you wouldn't have enough servers, it would be really crappy and everybody would go away. Instead, you pay some money, it's just like when I need to move, I rent a truck. I don't buy a truck and keep it. And I can get a nice big truck when I wouldn't be able to buy one. So, as I said, I think the best way to look at the cloud is really in these economic terms. It's the old version. I mean, it's the final realization of the old dream of utility computing. I mean, in the late 60s, the Multics people were talking about this as this dream of the future. Time sharing would give you utility computing. Well, it happened. It just, those guys retired first. And if you look at how the cloud grew, long ago, well, really there was Salesforce, a decade and a half ago, doing something. It was cloud. I mean, it was a very specialized cloud thing, a specialized application that was used by a really, really large number of people. And, you get Amazon. Amazon comes in, and they're not, and in each case, so Salesforce, you didn't have this, they weren't pushing a unique technology or something. They were, they were helping salespeople manage their information. Amazon wasn't saying, hey, go rewrite everything in this great new language and use this new technology. They were taking virtual machine images and running them. They were doing things that people were able to use, they were able to pay for. And that's really how the cloud grew, is as a market. You start getting more and more, now everybody and his uncle has something in the cloud. But what's happened as the cloud's grown, so yes, it was driven by the market, and the market was responsible for so much of this innovation because the things that people liked, they paid for, and the things, things that worked for them, and the things that didn't work tended to go away. But one problem that's developed as the services within each of these clouds becomes becomes richer, is we start realizing there isn't a cloud. There's a whole bunch of clouds. They're all isolated. There's walls between them. If your data is in one place in the cloud and your data slicer is somewhere else, you're out of luck. Not only that, but your cloud provider probably charges you a lot of money to move the data from their servers to somewhere else. They make it free to bring it in, but not to leave. So what we've created is, in a sense, it's grown into a set of walled gardens. It's almost in a way like, years ago, if you wanted online services and you weren't one of the lucky people with access to the internet, you had a couple of choices. And each of the choices had a bunch of different services within it, but you had to take a package. You got one, or you got the other, or you got, there were Prodigy or something. Then all of a sudden they open up the internet. We've got the information superhighway. I don't know, I couldn't come up with a good graphic for this, but there's everything everywhere. Anyone can put anything on the net, whether it's good or not, and you can go and you can find, whichever things you prefer and use them. It's, if you think back to the difference between putting a website up today and what you would have had to do to get a service in CompuServe back then, it's a huge difference. You opened up this, it's not just a marketplace of money, it's a marketplace of ideas. Anybody could put something up there and let people try it. So the question we had was, can you do the same thing with the cloud? Can you take all of these walled gardens and basically tear down those walls and replace them with, bright, shiny networks of cloudy goodness? And the answer to that is, I think we can. Actually, I believe we can. And the rest of the talk is going to be about what we're trying to do about this vision. Both the team, the project that we've put together, the plans that we have, and then some of the technical details, which actually tie in very well with what Jesse was talking about, because we're looking at OpenStack as well. So, our idea for doing this is starting with an existing cloud framework, I mean, there's a lot of stuff in a cloud framework. We're not going to go and create another one. But then, you know, cutting apart a bunch of the things and doing the surgery so that we can actually have multiple compute providers. We can have multiple storage providers. And in fact, you know, this is something that we're not the only people interested in this. I believe Jesse called it microservice integration and was also referring to some things about cross area that they would like to be able to do. And so what's it going to take? You know, what did we think it would need to take to do this? Well, one of the problems with, you know, especially as researchers, but even as engineers working with cloud computing, is that it's not one of those things where you're building the thing that you want on your desktop. I mean, let's face it, if you had engineers design the cloud service that they want, it would be optimized to run kernel compiles and Call of Duty or something like that. And another problem is that, you know, the whole point of a cloud system is to be big, something that runs at scale, that runs well at scale. Prototypes are small. So first, you kind of need a data center. You need a lot of computers. And like I said about, you know, what are the applications, it needs to be driven by real users running real applications. If you try to build a next generation cloud by having it run toy applications, you're going to end up with a system that runs toy applications. It's not going to run the applications of tomorrow. It's probably not going to run the applications of today. So it turns out that, you know, Iran was at BU, I'm at Northeastern, we were talking, there already is something like, we've got a data center. It's a long story, but basically some of the universities in Boston started looking for more space for their computers. Real estate's really expensive around there. They kept looking farther afield. They said, hey, let's get together on this. And so eventually 5 universities built this big 10 megawatt data center outside of Springfield. That canal feeds a hydro plant just down the road from them. So, and not only that, there was a bunch of computers and users too, because that's what they were looking for space for. I think that data center is close to half full now. So we do have the, you know, real scale, real users, real system, you know, something that we can observe, we can work from, we can figure out how to solve these people's problems. We need partners. You know, we're not going to do it with a few professors and a few students. We got the state involved. They're very much behind this. And a whole host of industry partners. Because they can see, because a lot of the companies in this area, especially companies working with private cloud, see how, you know, the possible value of a new model of public cloud computing where everyone can compete, everyone can try out their new ideas and make them available. Finally, you need people. Well, we've got some developers. Here's some of them developing away. They're great guys. And so we're finally starting to make progress on this. The next thing I'll talk, so what are we actually, so we've got a project. What does that mean? What are we trying to do? Well, we've got 3 phases to it. So the overall goal, we're trying to do an open cloud, a cloud that different providers can compete in the same way that, you know, different people can compete both for your money and for ideas on the internet. You know, anyone can put something up on the internet. We're trying to make a cloud where, well, not anybody, but any reasonable, within reason, people can put services here, both higher level services and with, the right agreements, carry in your own equipment, pay for, like co-location, pay for the power, and have users use your equipment within an open cloud. So we're starting off kind of gently. We've got some, a decent amount of compute capacity, probably 100 machines or so, that's available from various research uses where this is an appropriate use for them. We've got some donated capacity from some of our industry partners, so I'd like to thank Cisco and Dell here. And we're using that to set up a friendly cloud with, friendly early users. They tend to be friendlier if you're offering them discounted or free service. And, in this point, we're really building up the organization of the Massachusetts Open Cloud, some of the software for monitoring, metering, getting our DevOps team up, getting some of the services most important to early users. So since those users are coming from our institutions, there's a lot of high performance computing. There's a lot of also MapReduce. You see that being more and more widespread. At this point now there's English professors who use MapReduce to search over things like the entire history of the New York Times, the London Times. You can get the London Times back to like the 1700s or something. And so people are doing data mining, even in things like English. So at this point, in this first phase, we're doing some of the changes needed to support multiple providers. I think I mentioned some of them were referred, Jesse made reference to some of those. And it's going to start on the way to being self-supporting. There'll be some amount of fee charging, although that's probably more a subscription basis or membership than something like putting up your credit card. The second phase of the project is really where it's starting to turn into a real public open cloud. So here we've got software that, the software is maturing. We have things like full support for, selecting among different providers, compute from one provider, storage from another provider, maybe advanced networking functions from a third, not just at higher levels, but all the way down. At this point, the MOC, the Massachusetts Open Cloud, would be operating as basically the market maker or the middleman. They would provide the software infrastructure to make this hold together as a single public cloud. Things like a shared directory that providers would advertise their services into. They would probably be handling the things like power and space. We expect that organization to handle the billing and to run itself off of some commission charged on it. In particular, I think what really characterizes this second phase is we expect to see a lot more partner capacity installed in the Mass Open Cloud. And unlike the first phase, that capacity, that was donations. That was basically our startup capital. It's there to get us going. We can afford to give service, discounted service, or give some away free if it helps get things going. In this second phase, the reason that companies would be putting machines in is not as a donation, it's to make money off of it. It's an investment, because at this point, this system is open to the public, and they're charging for use, and it is a public cloud. Now, the partnership with the state, that's a project with a fixed period of time to build the Massachusetts Open Cloud, but it's not going to go poof and vanish after that project is up. You know, because of the unique circumstances, because it has nonprofit universities as well as for-profit companies involved, the Mass Open Cloud itself, the sort of umbrella organization, is probably going to become a nonprofit. Again, it would be the market maker, and you know, and would be controlled by the organizations that are, you know, that are working within it, that are selling through it, basically. Now, one thing, you know, I think that isn't as important with this crowd, but sometimes we have to stress that, you know, yes, there's some public money going into this, but this isn't, the goal of this isn't to create, you know, a publicly subsidized competitor to Amazon or something like this. The goal is to create a new model for cloud computing that, you know, if it works, this is going to be, this particular data center is going to be the least, you know, just a small part of the implementations of this out there. You know, the work we're doing is all open source. We're trying to feed it back. We're trying to get, you know, we're trying to work with the OpenStack Foundation even before we do a lot of the work to make sure that it feeds back in upstream and so on. So this is going to be available for anyone else to start an open cloud as well. And I guess the last part of the talk is how are we actually doing it? You know, this is the technical part. It's, you know, I mentioned before, we're starting with OpenStack. It's open source. That's good, both as far as money up front and also because, again, you know, some of us are researchers. It really doesn't make, you know, we're not building a private company or something like that. We're trying to come up with results that have, you know, wide usability. OpenStack has most of the needed functionality. There's a lot of stuff there. There's some things I'll talk about that aren't there. It's got broad acceptance. There's a huge number of people contributing to it. It takes a lot of effort to keep up. There's a lot of industry support. It's got, you know, all the apple pie things. It's modular. It's got good standard APIs when they don't change them. It's got a plug-in architecture. Never mind the red thing. That's Iran's. And so I guess the thing is, what do we need to do to go from this picture? This is sort of a highly schematized version of a single, you know, of an OpenStack installation. It's got its different parts. It's got, you know, Horizon's the user interface. Nova is the compute provider. Cinder is block storage, and so on. How do we go from that to this, where we've got a bunch of Nova providers? We've got a bunch of Cinder providers, and so on. So, you know, we need designs that can handle both basically a model to discover multiple services. We need to be able to locate the services. We need to harden some of the interfaces, and we need to provide for delegation in certain cases. And what we've found as we've talked to people about what we're trying to do is that although we seem to be the only people trying to build an open cloud out of OpenStack, I think every one of the individual things that we're trying to do, someone out there has said, oh, this would make what I'm trying to do easier. You know, even some of the things that Jesse was talking about involving, you know, being able to update separate, you know, services at different times. or being able to, handle failover across areas, things like that, where, current OpenStack limitations, it turns out that there's, they're running up against some of the same limitations we are for different reasons, but the same limitations. So the rest of the talk is really going into details on these. First, if you're going to have multiple providers, how do you pick the right one? If you're going for the cheapest, there's different factors you might be using. If you're going for price, Slacker Bob here probably has the best price. I apologize to anyone named Bob. He's going to get a lot of abuse. Or there's the reputable provider, or maybe you really need some special purpose hardware and someone else provides it. So how do you find the right one? Well, we envision a lot of that is going to involve, basically being able to create a marketplace that people can navigate. And not only that, this is a user interface. What you really need is something on the back end, a machine readable, a service directory that actually expresses all these capabilities in ways that an interface like this could understand. Think about, if you went to the Android marketplace and you were looking for a program that read a specific type of file, how would you find it? Just being able to browse through visually isn't good enough. We need ways of categorizing what plugs into what resources it needs, how it's charged, things like that, so that you can actually have, we expect most of the interfaces to this are actually going to be more special purpose ones, for, bundling together multiple things, whether it's looking for the lowest cost or looking for things that meet a certain reliability standard or something like that. Another issue is just how does OpenStack find an object, like a virtual machine or something? Right now, OpenStack knows about, it knows if I'm doing something with a virtual machine, I talk to Nova, the compute provider. Which Nova instance? Well, the Nova. That's all there is. That came up when Jesse was talking about multiple areas. So, we can handle, first there's the problem, okay, here, if we've got a choice of two different compute providers, OpenStack has to be able to tell the difference between them. It has to be able to conceive of or express the idea of there being multiple multiple service endpoints is what they are in OpenStack for a particular class of service. And then to make it even more complicated, you might have both of your two services going through the same provider, but then on the other end using different providers. So we need to be able to identify, here the red VM is going to Dick's Disks and the blue one is going to Robert's repository. And complicating this is the fact that, one of the design decisions in OpenStack is that objects are represented by UUIDs. Now, how much information does a UUID give you? Well, one thing. You know that it's different from every other UUID. You don't know what it is. You don't know what to do with it. OpenStack actually uses context to determine what type of UUID it is, and then passes it to, if it knows it's a virtual machine, it passes it to the Nova, if it knows, and so on. So we need additional mechanisms to be able to ensure that not just direct user requests, but indirect user requests go to the right place. Actually, this isn't as much of an issue, and I think it's being worked on. But one thing that does come up when you start talking about an open cloud is, the first thing that's going to come to everyone's mind is security. And that's because it's important. So today, with the cloud, basically, you trust your provider implicitly, except that you don't quite. If you don't trust a provider, you take your business somewhere else. But whoever you take it to, you've got to trust them. Now, let's say that our open cloud is happily working away, and our user here is happily, working with getting service from a trustworthy provider, and now Slacker Bob shows up again. Now, Bob may not be, Bob may be honest, but maybe he doesn't spend a lot of time on security. His machines get hacked. All of a sudden, it's not Bob, it's some guy from who knows where who's trying to get at you. We want to make sure that this can't happen. I mean, today, well, Bob and Bob's attacker, they're just part of the whole internet. They're no more or less threat than anyone else out there if you're on Amazon or Rackspace or something like that. They don't have a privileged position to attack you from. And we need to make sure that in an open cloud, if you're not doing business with a provider, they shouldn't be in a privileged position to attack you either. But it gets more complicated. We'd really like the same user to be able to use both trustworthy and non-trustworthy providers, or maybe trustworthy and really trustworthy providers might be a better example. And so we're worried that, here, well, we've got, the blue is really trustworthy, the red is not, and however, they're both storing data from, in separate volumes, but with the same provider. With today's OpenStack security model, if Bob gets hacked, well, with any of the virtualization technologies today, if Bob's hacked, then he owns your virtual machine. And so if he owns your virtual machine, he can get this volume. But what about this one? We want to make sure that he can't get to that blue disk, but today's OpenStack model doesn't let you do that. It just says, oh, it's on behalf of the same user, so I'll let it go through. So we're working on solutions for that as well, basically trying to get consensus behind some blueprints for OpenStack modifications. There's some issues with securing underlying protocols. I think this is maybe not as important a one, but one that is quite important is having networks span providers. So say we've got some virtual machines with Robert here, but then we need some really specialized machines, GPUs or FPGA accelerators or something that Robert just doesn't have. Well, we'd like to be able to put this together in an application that that isn't going across the internet or doing something similar. We'd like to be able to actually, use these together as if they were on the same network. How do you do that? How do you do seamless networking across different providers? For that matter, how do you cope, what if you've got a few different providers, hardware providers, one of them has Plexi for their networking and one has Juniper. We don't even know how to interconnect different classes of software-defined networking using OpenStack yet. And then there's one last thing that we've been working on, and this isn't the, this is probably going to become an OpenStack project, but it's sort of underneath OpenStack. And this is an example of one of those things where, you know, sometimes things are just driven by one of your use cases, but then they end up being much more general than you originally thought. In our case, you know, we tend to, I mean, you know, in a university research environment, there's a tendency to have a, you know, modest pile of machines, maybe it was funded by some grant, and you've got different people who are going to get access to machines at one time or another. You know, the orange guy here needs some number of machines for his, I don't know, maybe he's a biologist and, you know, and he's doing lots of genome searching or something like that. And then, you know, this purple guy, let's say he's one of my grad students, he needs a couple of machines as well. Well, in our case, you know, what we were worrying about, there's a big problem because, you know, if you've got this cluster of machines, well, if he's one of my grad students, he's going to need all sorts of low-level hardware access to the machine. Because we're not running nice, well-behaved user space programs. We're working on drivers. We're working on file systems and stuff like that. And that means he can do all sorts of nasty things to the rest of the network. Now, I like my grad students. I trust them a good bit, but I don't think that I trust my students and all these other guys' students to not ever do anything that might cause a problem or not slip and let someone else get into their machine and use that as a launch pad to get all these others. So what we've come up with is what we're calling hardware as a service. And this is different than you know, OpenStack Ironic or MAS in that it's not just a platform for running, you know, machine and images more efficiently. Instead, this is a tool for people who really want access to the hardware. And so we're using network isolation, network filtering to isolate different parts of the network for different people and providing gateways in the form of virtual machines to it. And this allows you to basically, you know, have real bare metal access in one of these partitions. If you want to deploy OpenStack using Fuel, for instance, which uses its own Pixie server and rolls it out to a bunch of machines, you can do that. If you have, you know, you can take existing deployment mechanisms and use them within, you know, unmodified within one of these partitions. So what we see, so we've been working with this. We see this as complementing some of the other things in the mass open cloud, because in fact this gives yet another layer of service that can be, you know, that can be provided flexibly. So I guess in closing, you know, just looking at the status of the project, we've got an operations team that's ramped up, or is ramping up at Harvard, Northeastern, and BU. We've got some initial dedicated capacity, 20 servers from Dell. The Cisco servers may be on a truck already, I'm not sure. They're real soon now. I've mentioned before, we've got experimental access to a couple of large clusters. And we have a development team, not just some people hired within, you know, the university side of the project, but also people from, you know, we've got people working on this full-time or part-time at Cisco, someone from the US Air Force. We've got this great guy who's actually sitting in our lab for 5 or 6 months working with us. Red Hat, there's a team from them working with us this week. Intel, we're working with Red Hat and Intel in defining blueprints, trying to come up with the designs to solve some of these problems. And the hardware as a service is approaching the first release. And then there's some business side stuff, but this is someone else's slide. So I guess that's the Massachusetts Open Cloud. We're trying to redefine cloud computing. That's all. Thank you.
Hi, I'm Stephen Ford with Georgia State University, and I'd be very interested in talking with you on, you said that you guys are ramping up and you already have 5 universities that built a co-location together.
Yes.
Where with Georgia State, we've got Georgia Tech right next to us, we've got the Board of Regents, and we can't even get people to share, a rack, let alone, so I'd be very interested in finding out how did you navigate the political circumstances within your governance and the actual politicians themselves, and how long did it take?
I will say, well, one comment is Jim Carosa is God, or ought to be, is wonderful. Disclaimer, he was on my thesis committee, but it's, there were some people involved who are, not only very good, but also seem to have the gift of talking to people in such a way that the people think that there's no other reasonable thing to do but agree with them. Mm-hmm. So those people are very scarce, but they're very helpful when you have them.
All right, thanks.
Oh, you said, what about integration with existing clouds? Okay. I see, basically that would be at a level of federation. So I can't see, having, a virtual machine on one side and it's, block store on the other side of a boundary like that. But definitely there's active work going on in federation. There's a whole bunch of use cases for it. Actually one of the big ones evidently is mergers and acquisitions, because now you suddenly have 2 OpenStack clouds. So that's something that we're going to, we'll be taking advantage of. In fact, we're partners with, there's an effort in Tennessee, the Tennessee Open Cloud, I think they call it, and they're partnering with us, and we expect that to be federated as opposed to, more directly linked. Okay, thank you.